Okay, let me go ahead and clear. Now, ready? So today we're gonna go ahead and continue. Now we're gonna go ahead and use a different strategy on how to divide. Some of you guys might like it, some of you guys might not like it, some of you guys might find it more simple, some of you guys might not find it more simple. Whatever the case is, it's a different strategy. It still gives you the same result. Now, what synthetic division is, it's basically like a shorthand or kind of when you abbreviate items or terms, you're going to go ahead and use this strategy to abbreviate and not write everything out how we do in long division. So what we're going to do here is that we're only going to focus on our coefficients and the constants. That's it. We're not going to write any x values, any power values, or anything else. We're just going to focus on the coefficients and our beautiful constants here in this case. Now, the only way that we can use this is whenever we have linear expressions as part of our divisor, okay? So we have polynomials. We've been going over this for a very, very long time. We went already over the strategies. We've been adding, subtracting, multiplying, factoring, dividing. Yesterday, we had our second day of long division. Today, we're going to have our first day of synthetic division, okay? All right, so go ahead and copy this one down. 3x to the power of 3 plus 22x squared plus 37x plus beautiful 10. This time it's going to be divided by x plus 5. Okay, so the way that we're going to go ahead and set up our synthetic division, guys, is that we're going to go ahead and create our little house, but this time we're going to go ahead and flip it around. We're going to flip it so we have our house turned around. We're turning the house upside down here. And we're going to go ahead and write every coefficient of our beautiful dividend inside of our house right on top over here. Okay, so here's my first coefficient, which is 3. My second coefficient is 22. My third coefficient here is 37. And my beautiful constant is 10. Now, before then, we always have to make sure that it's written in standard form, that every term is present in order, and that we don't have any missing terms in this case. Yes. No, I need to make my bottom part longer. There you go. Make sure there you go. Everything's inside. Now, the only way that we can use this is whenever my divisor is a linear expression, meaning that it only has an exponent of 1, and its leading coefficient is always equal to 1. That's the only way that we can go ahead and use this beautiful method. Now, whenever we had our long division, right? We had our number here, for example, 8, and we had, for example, 16. We needed to multiply by 2. What happens here? We subtracted the 8, right? So this value is going to be the opposite from here. The same thing is going to happen here in this case. So since the divisor is x plus 5, we're only going to consider now the constant that is adding or subtracting. But it's going to be the opposite value of it. So if it's positive, it's going to be -5. So I'm going to go ahead and write -5 outside as my little beautiful divisor. There you go. Now, my next step is to bring my first term down. So I have 3. I'm going to bring it down, and I'm going to start with my multiplication. So -5 times beautiful 3 is -15. Now I'm going to go ahead and combine these two together. 22 plus -15 is +7. Now -5 times +7 gives me -35. Let's go ahead and combine these two values together. 7 plus negative 35. Beautiful, positive 2. Negative 5 times positive 2 gives me negative 10. Let's go ahead and combine these two and it gives me 0. 0 is going to be my remainder here. Yes, that's it. So whenever I'm done, I'm going to go ahead and write everything out. I'm going to go ahead and start with the next highest power. So my highest power was power of 3. So then I'm going to go ahead and write now power of 2. So my first coefficient is going to be 3x to the power of 2 plus 7x to the power of 1 plus beautiful 2. And there you go. Which method do you guys like better? Now, the only reason or the only way that we can use this again if we have a leading coefficient of 1 and a power of 1. We're going to take the opposite value of this, write it right here. Bring down our first term down. Start multiplying. Negative 5 times 3, 15. Combine. Negative 5 times 7. Combine. Negative 5 times 2. Combine. And we get a remainder of 0. That's it. You should get the same answer. And this is the first example that we did on the first day of long division. So if you go back to your notes, you should be able to see that it's exactly the same. You guys identify it. Negative 5. So you can see where your divisor is. So it's up here. Yes, go ahead. Yes, miss. Yes, I'll go ahead and explain it again. Do you guys want to try another problem? Another example? Okay, let's go ahead and try another one. Let me go ahead and, everybody has this? Clear. Okay, now what is happening? Go ahead and write this one down now. X to the power of 3 plus 7x squared plus 16x plus 12. This one is being divided by x plus beautiful 2. Ahora sí. First step. Let's go ahead and write our beautiful house. Let's turn it upside down. So here's my beautiful house. Beautiful house. And I'm just going to write a line up here, meaning that I'm going to have my divisor right directly outside so I can go ahead and re-reference back to it. All right. Now, how do I write my values on top in my synthetic division portion here? I'm going to go ahead and look at the coefficients of every single term, including the constant, so I can go ahead and get those values. So what are my coefficients here? 1. Next one. 7. Next one. 16. And the last one. 12. Okay. Let me make sure I create my line long enough so it covers every single value. There you go. Now, what is my divisor? What am I dividing by? X plus 2. I'm only going to focus on the constant, which is 2. Now, it is positive 2 here, but I have to do the opposite of it, which is negative 2. This is always the opposite. And make yourself a note, opposite value. Notice here that if it's positive here, whenever you put it into your synthetic division, it is going to always be opposite. Now, let's go ahead and bring down our first term or our first value. Always bring it down. So we have 1. Now, let's go ahead and start with the multiplication. Negative 2 times 1. Negative 2. There you go. Then we're going to go ahead and multiply negative 2 times the remainder of here. So we have 7 plus negative 2, which is what? 5, positive 5. So now negative 2 times 5 is negative 10. Combine these two. I get positive 6. Negative 2 times positive 6 gives me negative 12. What is my remainder?
0.
0. Now, what did we say if we had a remainder of 0? Is my beautiful polynomial factor x plus 2? Yes, it is. So it is a factor. And let's go ahead and write what its division is. So what I'm going to take is that I'm going to go ahead and look at my highest degree here. Notice that it's a power of 3. So this is going to be a power of 2 plus x to the power of 1, which is just x. And then plus my beautiful constant. So now I have x to the power of x squared plus 5x plus beautiful 6 as my beautiful remainder. Much better? Okay. Okay, let me save an image. What time is it? Perfect. Ready for another one? All right. Ready?
Yeah.
The next one I'm going to go ahead and try on your own. Go ahead and try this one on your, actually, let me do this one with you guys. Go ahead and try this one on your own. Let's see if you guys can do this one. X to the power of 3 plus 5x squared minus 17x minus 21. And this one is divided by x minus 3. All right, so how do I set up my little beautiful house? I'm gonna go ahead and turn it upside down. Make sure I have enough space. I tend to write a little bit larger, guys, but here we go. Let's see who won last. Yes. No, it wasn't Stephanie. Clarissa? No. Jesus, pass it on. Okay, back to you, Jesus. Go ahead. So, what do we write inside my beautiful house here? Oh, sorry. Pass it on, Jesus. Kiana. I was like, Kiana. Gianna. All right, Gianna. Go ahead and tell me, what do I write inside my okay, so my little coefficient of 3, x to the power of 3 is 1, 5, negative 17, and negative 21. Awesome. Okay, let me go ahead and expand my beautiful division house here because I always write larger than what I want. Okay, now, Gianna, pass it on. Luis, what do I write as my divisor? Negative 3, close. What did we say we needed to do whenever we focus on the constant? The opposite of it. So be positive 3. Make sure that we write the opposite of it. All right, Luis, pass it on. Maria, what do we do next? We have to bring that beautiful 1 down. Thank you. All right, Maria, pass it on. Michael, what do we do next? Okay, so multiply the 1 by 3. That gives me 3. Where do I write it? Below the 5, so 3. There you go. What do I do with these two values? I combine them, so I get 8. All right, Michael, pass it on. Nick, what do I do next? Multiply the 3 and the 8. 24. And I combine these two and I get positive 7. Pass it on. Jesus? Jesus, what do I do next? 3 times 7, which gives me positive 21. So I multiply the 3 times the 7, gives me positive 21. What do I do next? I combine these two and I get 0. So is x minus 3 a factor? Is it a factor? Yes, it is. So 3 minus x is a factor because we have a remainder of 0. Remainder is 0. So how do I write now my beautiful polynomial? Jesús Pastrana. A ver, Julio. X squared plus 8x plus beautiful 7. Raise your hand if you were able to get that. Let's go, guys. Let's go. Remainder is 0, and therefore we have x squared plus 8x plus 7. All right. I hope you're feeling more comfortable with these guys. Let's go ahead and step it up. Let's see. Not this one. Let's go ahead and try this one. This one. The other one? No. Okay, let's go ahead and try this one. All right, let's try this one then. X to the power of 3 plus 8x squared plus 17x plus 10 divided by x plus 5. Let's go ahead and see if x plus 5 is a factor or not, and we'll go ahead and discover. So do you guys want to solve this one on your own? Yeah. Okay, go ahead and try this one on your own again. All right, so what do you guys think? Is x plus 5 a factor or not? How do you know? There's no remainder. So let's go ahead and solve for it and see if we can compare and contrast. Here's my beautiful long division. What do I write inside my beautiful house? 1, 8, 17, and 10. Perfect. Now, what do I write outside? What do I write outside, guys? -5. All right. So let's go ahead and bring down my beautiful 1. Multiply -5 and 1, it gives me -5. Combine these two, it gives me -5 times 3 gives me -15. Combine these two and it gives me -5 times 2 is -10, and combine them two and I get 0. So it is a factor. However, what is my beautiful remainder here? X to the power 2 plus what? 3x plus beautiful 2. Okay, let's step it up now. Everybody had that? Yes? Okay. All right. Too challenging, too challenging. Okay. Let's see. This is our last one for today, guys, and then I'll go ahead and give you guys a worksheet. All right, so go ahead and copy this one down. 7x to the power of 3 minus 6x plus 9. Not yet. Don't stop it yet. Hold on. Okay, guys, I need it quick. All right, so I'm going to go ahead and set it up. Here's my little house. And then I'm going to go ahead and write my coefficients and my beautiful constant inside. However, guys, notice here that I have 7x to the power of 3, negative 6x plus 9. Which of the terms is missing? X squared. Yesterday, I told you guys whenever we have a term missing, we put a leading coefficient of what? 0, not 1, not 0. The same idea is going to continue here. So you're going to go ahead and have now 7x to the power of 3 plus beautiful 0x squared minus 6x plus 9. Let's not forget to allow a space for this term to be there. It's not present, so we have to make sure that we have a 0 as a coefficient. So now we're going to go ahead and write my beautiful coefficient, 7. My next one is 0. My next one is negative 6. The next one is 9. Outside, what do I write? It's positive 5, so it's now negative 5. Okay. Now, same procedure. Let's go ahead and bring it down. 7 down. Negative 5 times 7. 35, negative 35. 0 plus negative 35 is negative 35. 5 times negative 35. Positive 175. Combine these two and I get 169. Negative 5 times 169 is? You guys have calculators? 845. Combine these two together and I get? It's negative, yeah, negative, sorry. There you go, 800 and? There you go, 836 negative. 36.
That's when you use me. Like now I don't know.
Now, is x plus 5 a factor of 7x to the power of 3 minus 6x plus 9? No, why? There's a remainder other than 0. So therefore, this is not a factor. X plus 5 is not a factor. It doesn't fit in there perfectly fine. So therefore, we have a remainder. Therefore, it's not a possible factor. We can go ahead and write it as a divisor, guys, where we have our divisor times our quotient and the remainder. So here we go. So our highest power of x to the power of 3. So we have 7x to the power of 2 minus 35 beautiful x plus beautiful 169 plus our beautiful remainder of negative 836. Yeah. So this is our response right here. Let me go ahead and look at my screen because I'm not looking at my screen. There you go. Woo! There you go. No, I was just explaining, guys, that it was not a factor. X plus 5 is not a factor. Yes.
What's the origin?
Remainder. Yeah, remainder. There's a remainder. There's a remainder. Okay. Any questions on this, guys? No? How do you feel about these synthetic division? 5 being that you're good to go. 4 meaning I still need a little bit more practice. 1, I'm still totally lost. Okay, I got it. So we're gonna go ahead and practice a little bit. Let me go ahead and give you guys your worksheet. And then you guys can go ahead and practice while we're in class.